let's kill it. Then I prefer working with cloud services, so the exam is simpler. CCE, so all of this is in preparation to discuss CCE later. CCE is Huawei's Cloud Container Engine. The first C stands for cloud, the second C stands for container, and the third E stands for engine. Does it mean engine? So does it all come together as Cloud Container Engine? The prerequisite is that you need to have a foundational knowledge of containers. So someone just asked if we are done with HCS. I said I didn't say it was finished. So this CCE is called Cloud Container Engine. It is designed to enhance this capability, and Huawei's CCE clusters are based on the Kubernetes and Docker container ecosystem. It fundamentally uses Docker and K8s. All right, so it is a lightweight virtualization solution. A lightweight virtualization solution based on container technology. It utilizes two core technologies. One technology is called namespace. Everyone knows it's used for resource isolation, and the other is C group. C group stands for controller group and is used for resource limitation. What does that mean? Suppose today I run 100 containers on this host. Can I limit the resource usage of each container? Because it's essentially a process. You control the process. How do you control the use of CPU and memory resources? If it runs 100 containers, it's like running 100 processes. How do you limit the resource usage of each process? And you know about running virtual machines. You can specify the CPU and memory when creating a virtual machine. What do you do when working with containers? How do you specify it? It uses C group technology. C group technology. Got it? It's used for resource isolation. Later, I will spend an hour explaining C group, the working principle of C group and its cases. All right, to thoroughly understand C group. So, Docker containers. Today, we only talk about Docker. In fact, many other technologies today are similar. Docker essentially represents virtualization, not the standard for containers. You say I've learned Docker. Will I know Podman? Will I? Huawei uses a container technology like this. Okay, it has achieved standardization, ensuring a consistent operating environment. Elastic scaling, rapid expansion, easy migration, continuous integration, CI and CD, continuous integration, continuous delivery and deployment made easier, high performance, no need for hardware virtualization or running a full operating system. Understand this? No need for virtualization, right? No need to run a full operating system, right? And quick startup. And it can achieve process isolation. Just mention. Does it use namespaces to achieve isolation between processes? Just like how virtual machines isolate different tenants. It achieves isolation and is more lightweight. Why wouldn't you want that? Doesn't it solve the problem of not being able to run multiple applications on the first generation physical machines? Through this method, isn't it now possible on other to run on physical machines and save resources and achieve resource isolation? So from the first to the third generation, it went through virtualization. Of course, virtualization isn't just a step. It's not that containers will replace virtualization. All right, on the left, the infrastructure runs the host operating system, running a Docker, running various containers on it. It's the same here. Look at the operating system containers, the containers under Docker. You see this? Isn't this just a virtual machine? Does this look like a virtual machine? The client is based on a physical architecture. Isn't there also a virtual machine running on top? Inside the virtual machine, applications are running. Isn't this directly running multiple applications now? All right. What about Docker? It's actually about understanding this diagram. Understanding this diagram explains Docker. Actually, Docker is quite simple. Docker is simple. First, we have a Docker client. That is, we have a Docker service called Docker daemon, just like OpenStack. Our client commands, such as OpenStack server list, OpenStack volume list, OpenStack volume creator. These commands can run on OpenStack nodes. Can they also run on non-OpenStack nodes? Right? As long as we have the corresponding client commands. Then source environment variables. Can we also run OpenStack commands on other machines? Manage OpenStack. Docker is the same. Docker clients can be on Docker nodes. Or on nodes that are not Docker specific. Just for client use is also possible. But usually, like with OpenStack, we manage on OpenStack nodes. It's the same here. We usually manage Docker on Docker nodes. All right, next. Our Docker images are just like the images we make in the cloud. Docker also has its own images. And in the cloud, we know there are many images. Like we make a CentOS 7 image, right? We make an Ubuntu image, make a SUSE image. We install the software we want inside. Similarly, containers also have images. Then this container is called Docker container. And it has a Docker repository called registry, called Docker image repository. That's about it for these things. Very simple. So the process goes like this. The image repository is here, called Docker registry. This registry can be official. The official repository can also be a private repository. Okay, let's take a look. When learning Docker, there's a website you must know. It's called Docker Hub. This website is overseas, so the access might be slower. The website is slower from abroad. To solve this issue locally, a mirror site was set up. Mirror site. Both Huawei and Alibaba have one. Let's look at Huawei. Huawei has a dedicated image repository called SWM. Here, we can have private repositories here. Look at my own images. Look, I've uploaded many images. See that? These are my own uploads. There are many here. These private images. There's also an image center. These are uploaded by Huawei. There's also an image accelerator. Up here in the right corner. Image accelerator. Huawei also provides us with an image accelerator address. Here. This is a local mirror site. It's just an address for a mirror site. You can't log in. Because the overseas site can't host this. Not this. It should be called Docker Hub. It automatically redirects to hub.docker.com. This site is a bit slow. This site hosts hundreds of thousands of container images. Only what you can imagine. There's nothing it can't do. Any image you need is already prepared for you. This is the official image site. It contains 100,000 pre-made images you might need. 100,000. These are prepared by others. Both public and private images are available. Your private images can be uploaded to Huawei's image repository. You can also upload to this official image repository. Therefore, there are 100,000 public images available. You can download images for all sorts of services you may want. Others have already prepared them for you. They are all ready for use. Just take and use them directly, unless you need a company-specific image. Otherwise, you don't need to create your own. They are readily available. Let's look at Alibaba Cloud. Alibaba Cloud also has So which cloud today doesn't have containers? That would mean they are half obsolete. Thus, containers are a must-learn for cloud computing engineers. Not just for career advancement and salary increase, but a necessity. Today, which company running on the cloud doesn't use containers? It's impossible, right? You need to understand both OpenStack and containers. Right? Alibaba Cloud also has an accelerator, right? Look, there's also an accelerator address. It tells us how to install Docker, how to install it in Ubuntu, how to install it in CentOS. And this address is my private one. Generally, when writing articles, we would blur this part out, not letting you see, because the prefix of each user is unique. It is unique, including the computing site at Huawei. I wouldn't give you mine. This ID is uniquely generated for me. Each person, when you log in with your account, the system will generate a unique string of ID for you, a unique ID that owns your image repository address. Many people wonder if using someone else's images is unsafe. Here's the thing. The image repository doesn't just provide you with images. It will show how the image was written. Every line of code is listed there. So I have 100,000 container images, right? The code for each container image is entirely listed inside. So, can you feel secure about that? Here's a specific Alibaba Cloud image repository. It has a specific container. See that? Inside the container, there's information about Docker and Kubernetes. We click on Docker CE. Here it will tell you how to install Docker. How to install Docker. It's all here. There's also K8s here. Domestic mirror site. Domestic mirror site for K8s. How to install K8s. The documentation is all here. Unfortunately, this website is often hard to access. I just wanted to show it quickly. Just a quick glimpse. You don't have to keep looking afterwards. I wanted to open it just once to show it. My goodness, it's particularly unreliable. It won't open at first. Inside, you can find any image you want, 1223, and each image shows how it was written. All the code is available. All of it is available. Okay, let's continue. So we call this what? The image repository here. Foreign websites are very slow. To solve this problem, many domestic mirror sites have appeared, right? Like Huawei or Alibaba both provide mirror sites. And many third parties also offer similar mirror sites. For us, as users, it's like this. This is the client. We execute a command called Docker pull. Docker pull is to pull images from the image repository. Pulling images from the image repository using the command called Docker pull. The Docker host runs a Docker service. Of course, these two can be the same machine. They can be the same machine. Or it can be a dedicated client machine. But usually, we run them together. It runs a Docker service on top. Then we execute Docker commands to pull the image to our local machine. The command we use is called Docker pull. The image we pull, where does it actually come from? From the image repository. Where is the image repository located? Overseas. There are also many mirror sites domestically. Okay then. All right, next, we use this image similar to how we use a virtual machine image. The virtual machine image. What do we deploy with this image? Is it containers? Deploy containers. Look, deploying containers. We use images to deploy containers. We deploy containers one by one. Through images, we deploy containers. That thing is called a container. That thing is called an image. So here's a service. To run containers, use Docker run. To download an image, Docker pull. To build a new image, we customize our own image, like this. In the open source Open Drive, can we not create our own image? Then here we would use Docker build. All right. Today I'll teach you containers in just one afternoon, okay? It's very simple. Normally when we teach, for example, Docker plus K8s, 24 or 30 hours. We only talk about Docker for one day. Just 6 hours. Docker for 6 hours. The rest is all about K8s. That's how it is. Like today, we talk about virtualization. Single machine virtualization takes one day. That's how it is. Isn't it about enterprise level virtualization? That's the idea. All right, let's get started then. Let's get started. Like this, I'm now on my machine. I have a CentOS system. My IP address is 2.216.206. Anyway, no matter what you do, you have to connect it to the internet, because the download will be from the internet later. Many times you have to be online. Just like installing packages. If you can't connect to the internet, then set up a private repository. It's the same principle, right? Okay. Next, let's start. We installed CentOS. I haven't done anything else. Just connected it to the internet. Got it online. That's all I did. Just now, we spent an hour introducing what containers are, right? The advantages of containers, and the relationship between Docker and K8s. Did everyone understand? Folks, I just spent an hour on this, talking for an hour. This is what you don't like. You like to get straight to action, not fond of first clearing up the basics. What we learn about containers today is unrelated to anything we learned before. Just a little bit of basics is enough. Just a little foundational knowledge. Don't say that because I didn't have the basics, I couldn't learn. Everyone starts with the same basics. There's no such thing as having prior knowledge, so I learned. Everyone starts from zero with containers, okay? Everyone is at the same level. All at the same level, as long as you have a little. The basic knowledge we learned about IP before is enough. Okay, I randomly pick one like this. Docker has many versions. One version is called Docker CE. CE stands for Community Edition, which is enterprise grade. It's one version. There are other versions too. Here, I now go into Alibaba Cloud. I'm in Alibaba Cloud. How did Alibaba Cloud come about? You do it like this. You type mirrors.alibaba cloud just to access the mirror site. It will automatically redirect. Mirrors with an S.com of Alibaba Cloud. It will automatically redirect. Mirrors with an S.com of Alibaba Cloud. Type mirrors.alibabacloud.com. Navigate to this container here. Open the Docker CE section here. You just need a machine that can connect to the internet. If that's not possible, you can apply for a host in the cloud. A machine with 4 GB of memory will do. I've allocated 8 GB of memory for it. 4 GB of memory, 100 GB of space is enough. That's enough for experiments with just one machine. 4 CPUs will suffice. Okay, next. I'll teach you how to install on Ubuntu. This is the Ubuntu version. Actually, I previously wrote a lab manual. It was done in Ubuntu. Because running containers is also very popular on Ubuntu. And Ubuntu may perform better than CentOS in running containers. Ubuntu has better support for containers. So in production environments, many times, containers are run on Ubuntu. Of course, CentOS works too. Okay, next up here, we'll use CentOS 7 as an example. First step, we install some necessary software packages. So, have you set up your YUM source? Is your YUM configured properly? Is this the default YUM from CentOS? It's the built-in YUM source from CentOS. Because your machine can connect to the internet, you can directly use its built-in YUM source. The built-in YUM source. Of course, you might wonder if you can use another YUM source. You can. Directly use Alibaba Cloud's YUM source. You can also use Alibaba Cloud's YUM source, because using CentOS's own YUM source might connect overseas and be slow. Potentially slow for package installation. For downloading, it might be slow. In the future, for package installation, downloading might be slow. So, here they provide us with one from Alibaba Cloud. You see, Mirrors.com offers one. One like this. Don't worry about the speed. This sentence means subscribing to Alibaba Cloud's YUM source. You see, is there not an additional YUM source here called Docker CE? You see, this path is all pointing to Alibaba Clouds. See that? Then change a few settings and then start installing Docker. Just setting up a YUM source to install Docker is that simple. First, create a cache. Whether you create a cache doesn't really matter. Create the cache. Then next we start installing Docker CE. Docker CE is one of the versions of Docker. It downloads through the Alibaba Cloud source. The installation is faster this way. Much faster. I didn't make any mistakes just now. You must have copied it wrong. Why is there an error with this command? It was fine just a moment ago. Okay, once Docker is installed, start it. The service is called Docker. Docker is now installed. Simple, right? Then Docker. Check its version 24. The latest version of Docker 24. Here, use Docker version to check its version. Right here, versions above 24. Our Huawei K8s, Huawei's CCE is based on K8s and Docker. See that? Based on K8s and Docker. It all uses Docker below. Simple, right? Installation is complete. But as I mentioned, using overseas image repositories is very slow. It defaults to using overseas repositories. So we need to use a domestic accelerator. You can use Alibaba's. Of course, you can use others too. I already have one set up. If not, I'll teach you a method called Docker. Search for Docker accelerators. There are many online, see that? Look here. Is it about installing and configuring accelerators? See that? It's called a Docker accelerator. That's what it's for. Do you understand accelerators? Because it's slower from overseas. So, big companies like Huawei and Alibaba also provide this kind of service. For example, I go to Huawei's official website. There's a Huawei Container Image Service, SWR. Here, I have my images also in the image center here. In the top right corner of the image center, there's an image accelerator. It advises installing version 1.11.2 or higher. That definitely won't be a problem. Okay, the accelerator address is here. Next, how do you make the system recognize this? Modify the configuration file under the etc folder of docker daemon.json file. Run this file, press enter. This address is unique to me. Your address might not be called this. Okay, copy this down. Be careful, pay attention to this semicolon. Don't copy it wrong. It has a curly brace. Inside the square brackets is the address of its image accelerator. This is the address of its repository image. See that? Is it called the repository image address? Copy it here. Don't copy it wrong. And don't include anything extra. Copy it over. Save. Then start it up. Restart Docker. Then check if the Docker image accelerator is effective. Restart it using a command called docker info. See if our accelerator address is effective. Is it effective? See? It is effective. It is effective. All the preparation work is done. Much more convenient than installing OpenStack. How many times simpler? OpenStack hasn't even installed the packages yet, while Docker is already installed. What next after installation? Run business applications. Start running business applications. How do you run business applications? It's simple. All the preparatory work is done. I've taught everyone the method. The image address is here. You figure it out. Image accelerator is here. Here. Docker info can show that it's configured successfully, yourself in this place, in Huawei Cloud's container image service. I recommend that everyone who doesn't have a Huawei Cloud account should register one. Register one and verify it with your real name. We will need it for experiments later, especially for experiments with CCE. The CCE in a private cloud and the CCE in a public cloud are the same. The exam has 3 questions. If you practice using a server rack, you might have to queue for a rack. If you don't want to wait, it costs 7 or 8 yuan per hour. To do this experiment, it's 7 or 8 yuan per hour. If you want to save money, then you might have to wait. So I suggest that everyone do the experiment on this platform as much as possible. Just budget 100 yuan. Anyway, you're spending that much money. If you fail the exam, that's not just a little money. That money could fund many experiments. Okay, about this experiment, next week, I will specifically teach everyone how to conduct it here. With a foundation in Docker, I will guide everyone through all the relevant experiments here. Good. We finally finished with Docker. Okay, let's start now. The lab I wrote is for Ubuntu. Just adjust the previous step slightly. And the rest of the steps are the same. The remaining steps are the same in Ubuntu and CentOS. The remaining steps are the same. Okay, starting from the accelerator here. Here's the accelerator. Now, starting from point 6, Docker's container management. Let me show you. Today, let's install an Nginx, okay? Download an Nginx image. The command is simply docker pull Nginx. It's that simple. If you don't specify a version, it downloads the latest version. You can also specify a version. Container management, pay attention now. We now start downloading a container, downloading an image. If you don't specify a version, the version defaults to latest. Wow, what the heck? No matching host. Resolution failed. What the heck? It seems it can't resolve this. Oh, maybe it's a problem with my DNS? Change the DNS. Change it. DNS issue, it's good now. It was the DNS from my router. The router's DNS couldn't resolve this foreign website. Now it can. It's good now. You see, our download speed is very fast. We are now downloading an image, just like our Cinderella image. We have a command called Docker Images. You can see this image, 143 MB, updated 2 weeks ago. What does this indicate? It shows that Docker's website updated this image 2 weeks ago, and it's the latest version. The image ID was updated 2 weeks ago, size 143 MB. They made this container image 143 MB in size. If it were an operating system image, I estimate it would be at least 700 to 800 MB. Right? Here we only have a bit over 100 MB. Okay, do we have a container now? Let's run a container. Normally, you would use docker create, then name web01, then nginx, append the container's name, and hit enter. Now look, docker psa. The container has already been created. No, created. Created, it's called create. Docker start, append the identifier 11b. Now look again, docker psa c. The container is now running. The container is now running. It's listening on port 80. Look, the container is now running. It's been running for 6 seconds. See that? It's been running for 17 seconds now. So the way we create a container is like this. The first step is downloading the container image. This is creating the container. At this point, it actually becomes a container. It's that simple. It's done in a minute or not even a second. A second is an exaggeration. Maybe 5 seconds. It can definitely be done within 3 seconds. We've created one, downloaded, and now we've created a container. Don't you need to specify an image? Isn't this the name of the image? Didn't I just download an image called nginx? So here isn't the image name specified. Using this image, a virtual machine was deployed named web01, right? Then run the container. Using this is to check the container. Running the container. The method to check containers is docker ps. A list all containers, including those running and those not running. Without a, it only shows all running containers. What is this 11b? It's the container's ID. This container's ID. Can you just enter one line? That works too. As long as your ID uniquely identifies the container in the system, it just needs to uniquely identify the container. It's the container ID here. Even if you just enter one, it's okay. Because at this moment, there's only one container. Entering a page works. Now I want to access this container. How do I do that? It defaults to using the host machine's port, which is what? 192.168, 2.106. Open a browser. Hit enter. The firewall is not off. I'll check. I'll turn off this firewall. Otherwise, it blocks port 80. If you're on a cloud, in the security group, you need to allow port 80. Turn off the firewall, okay? Try again. 2.106 docker PSA. We've mapped port 80. We've mapped port 80. It's port 80. I'll do another one. Docker, we directly run. What did I just recognize? Docker create, Docker pull, Docker create, Docker start. Actually, one command can do all three things. Notice that the port was not specified just now. Possibly docker PSA. I'm going to delete this container first. RMF11B. You see, this container has been deleted. The method to delete a container is here. Delete container. Use this command to delete the container. I didn't specify the port just now. Okay, now I'm going to handle those commands all at once. Docker run, running the container. DD stands for detach, running it in the background. P stands for port. Port 80:80. Just now name web01 using N word. What this sentence means is, I want to use the N letter, this image, to deploy a container called web01. I'll map its port using port 80 for mapping. The back 80 is the container's port. The front 80 is our host machine's 80. It's as if accessing the host machine's 80 is equivalent to accessing the container's 80. It actually uses IP tables policy. D is for running in the background. DP8080. What's happening? Mistake. No problem. What's going on? Docker run. Let's do it again. Docker run. DP. No problem. 8080. You don't need to use the name if you don't want to. I was wondering what was wrong. the firewall can't be off. After it's off, it can't map anymore. Documentation. Look, what's the real principle here? Look at this rule again. Why can't the firewall be off? It actually has a rule here, which is when you access, look here, when you access my host's port 80, isn't it mapped to your container's 80? This IP address is the container's IP address, 172.17.0.2. Port 80 is the container's. Accessing port 80 is like accessing the container's 80. Okay, next look. Now, have we accessed Nginx? I've accessed Nginx's container's address, the web server. I've accessed the container. So just now we executed one command. It's this one, just docker run. It's like doing everything at once. Executing the create and run commands. Running a container, directly running a container. Creating and running, it just does like docker run. It includes both creating and running. D is for running in the background. P is for specifying port mapping. Specifying port mapping, when you access 80, it's equivalent to accessing the container's 80. Ultimately, you access the host machine's port 80. You see? Is it not accessing the container inside the web server? Okay. Next, look. We docker run DP. If you want to run multiple web servers, what do? You add other ports, for example, HTTPD. This command equals 3 commands. The first command is downloading the image. First, if you don't have the image, you need to run to download through the image. First, you download the image, then create the image, run the image. 3 commands done together. You see, have I not run this Nginx? Docker, S4, you see I ran 2, another one. The first container is Nginx's. This container, I named it Web01. The second one, I didn't specify a name. It automatically generated a name for me. Generated a name, used 8080 mapped to 80. So it effectively added a rule, you access 8080. Did it access the container's 1720, 1770.3 port 80? So on your browser, add 8080, and there you see the result from Apache. So if you originally wanted to set up a server, you'd first need to install a virtual machine. Then you'd install packages on that virtual machine. And after, start the service. Configure it. Too troublesome. Now, I only need 1 second to set up a container. This container can work immediately. The container is operational. You see, I've set up 2 containers. One is with this container ID, and the other with this container ID. You see, we mapped 8080 to 80, and another from 80 to 80. The name of the container doesn't matter because in practice, you will hardly use the name of the container. The name can be randomly generated. All right, does that work for you? It shows here. The first one is the container ID. This is the name of the image. You can find this by command. Check if you downloaded 2 images. And this is the running time of the container. It has been running for 3 minutes. See, it was created 3 minutes ago. Created 3 minutes ago. Has it been running for 3 minutes? Details of port mapping. This is IPv4. IPv6 address. Name of the container. And this place is where we run containers. Running a script when running containers. When running containers, it automatically runs a script. When we talk about Docker fail later, I'll focus on explaining the script inside. I'll explain in detail this script inside. Okay. All set. We've basically learned some basic container management. As I just mentioned, containers do not have an operating system. They only have user space, not kernel space. Their kernel space is actually using our host machine. Which is why they are very fast and take up very little space. A container is created quickly. All right. I can also quickly enter the container to modify its contents. How do I modify it? Docker exec. It then attached to this container, like 391, add a bin bash. I enter this container now. I have entered this container. We enter the container. Entering the container, Docker exec. I is for interactive, meaning interactive interface. T is for terminal. Open a terminal. Open a terminal. Open a terminal. When you enter this container, let it run a bin bash. Isn't it running a command line? So this command has become like this. Added to the container's 80 port. I didn't add any. One is 8080. Another is 80. These two definitely can't be reassigned. Isn't the back 80 the container's port? Are all your running containers using port 80? Isn't your host machine using 80 mapped to the container's 80? Isn't the host machine's 8080 mapped to the container's 80? All right, I've entered the container now. You notice when I execute EDF inside the container, I also have 50 GB of space. You notice it's the same as the host machine. My host machine also has 50 GB of space, right? In fact, those two containers you just created are located here. Your recent containers are stored in var lab. Docker this directory. The space occupied by your containers exists here. So, they actually use the space of the host machine. See that? Didn't install that. If it looks at memory, it also sees the host memory. You see, it sees the host's memory, 8 GB of memory. See the host's 8 GB of memory. And you find many commands are missing in the container because the container is made minimal. Why do you need so many commands? They're unnecessary. Why? Because it's made only to run a service. You are just meant to run a service. Why do you need so many commands? Okay, next. Where was that just now? It's in USR. Share NGINX, there's an HTML. Inside this container, I'm in the container, you see the content. Is this content? So here I am, one gulp, Docker 66. I'm changing this file inside the container. Hit enter. Is it Docker 666 now? Did I change its content? Did I change it inside the container? This index file's content, is it now showing Docker 666 here after refreshing? Good. I've entered the container. I can exit the container from here. Am I back on the host machine now? I can exit the container. Did I return to the host machine? Entering the container. Being in a container is just like being in a virtual machine. You can operate it however you like, right? And you don't even need to restart services. What services to restart? No need to restart services. Can you set the location of the container and the image? Of course you can. Of course. Actually, there's a parameter for that here. The image parameter specifies where all our containers are deployed. By default, if you don't specify, it's under VAR lab. You can change the container's location with this parameter. Of course. Look, I'll make a folder. All future containers will be deployed in this folder. Can I? So, containers are incredibly convenient, incredibly simple. After you learn it, you'll find, wow, containers can run just fine. And look, I've run 2 containers. To the system, they're almost imperceptible. They consume very little resources. Only when accessed, you see, they use very little resources. Did you understand this part? I'll review it again later. I'll review it again. Did you understand? Containers are for running services. Just for running services. You don't need the host machine or an operating system. Right? No need to operate like a virtual machine. Running for 5 minutes, it starts instantly. If you need to install an application and there's no image in the repository, does that mean it can't be used? Of course we can use it. We can customize containers. We can create our own container images. We can turn our service into a container. Turning my own service into a container. And configure copy it here to where I am now. Awesome. I open it, make changes on my local machine. After making changes, Docker cp, copy. Copy it back into the container. Why even go into the container to change it? Just use Docker copy, that's enough. Can you see how powerful this is? Isn't that impressive? So you understand, after learning about containers, you won't want to deal with anything else. Using containers is too convenient. There are many tricks and skills you wouldn't imagine, all of which will gradually unfold for you, right? Just learning this little bit, tonight you can go back and let loose. You can start working, performing some basic operations. I will continue to supplement this to make your experiments go smoothly tonight. Okay. Shall we take a break first?